So in part one, let's start off by looking at the breathing mechanism itself. So here we've got our skeleton, and the lungs are like two balloons lying inside the chest itself. So we need to get the air into the lungs. And once that air is into the lungs, we then need to extract the oxygen from the air. We need to transport that within the blood system to where the muscles are working to provide us with energy. So we've got a couple of different mechanisms. So the first mechanism is ventilation. That's getting air into the lungs themselves. Once that air is in the lungs, we need to extract the oxygen, and we then need to use that. And so that would be our respiration. So ventilation to get the air in, respiration, the sort of chemical process to extract and use the oxygen. So if we imagine the lungs as two balloons lying inside the rib cage, how do we get that air in? Well, the first mechanism would be to simply say, well, it's just like a bellows. Can't we have muscles attaching to the lungs where they would push and pull the air in and out of the lungs? Now, whilst that would work, it would be quite an ineffective mechanism because, of course, when those muscles got tired, we wouldn't be able to breathe anymore. So we have an additional mechanism, a different mechanism, which allows us to breathe continually, to breathe throughout our lives, and it's very low in its demand for energy. So essentially we have a barrel, and that barrel consists of the rib cage, and then it's sealed at the bottom by the diaphragm, which is a muscle attaching to the bottoms of the ribs and going horizontally across the trunk, so sort of cutting us in two. And what we are able to do with this drum is to move it, so expand it and contract it, so we can make it bigger and we can make it smaller. And as we make it bigger and smaller, the pressure inside it will change. So if we make the barrel of the chest larger, the pressure reduces, and then atmospheric pressure, the pressures that we have normally in day-to-day living, will push the air into the lungs. So rather than us having to actively pull the air into the lungs, atmospheric pressure is pushing the air into the lungs. So if you watch one of these old sci-fi films where the villain goes into a vacuum chamber, they can't breathe, because if there's a vacuum, our mechanism breaks down. So atmospheric pressure causes the air to be pushed into the lungs. Okay, so we've got to have a mechanism then to make this drum, this rib cage, bigger and smaller. So firstly, it has to be movable. And it's movable because each of the ribs has a number of joints. So the rib is a little bit like a U shape, and as it comes around the rib cage, at the front it is attached to the breastbone, to the sternum. So when we talk about ribs, the name of the rib in anatomy terms is costo. So this is the sternocostal joint. Sternocostal joint is the junction between the rib and the breastbone itself. And we also have at the end of the rib a piece of softer cartilage. And that piece of softer cartilage has a joint within itself. And then as we turn the skeleton around, the rib then joins onto the spine, and it joins directly onto the spinal bone, so that would be the costovertebral joint, so vertebra being the spinal bone. And then it also joins onto one of the arms, which comes out of the vertebra, and that's a transverse process. So we have the costo-transverse joint. So essentially we have a U shape with a joint at the front and a joint at the back. And that enables the rib to move in two ways. Firstly, it can move up and down like the handle on a water bucket. And that is called a bucket handle movement. And it allows the rib cage to expand laterally. So when we're in exercise classes, yoga classes, Pilates classes, for example, we often talk about lateral breathing, and that's literally expanding the rib cage out to the side. So the second thing that we can do is we can keep the sternum, the breastbone, fairly still, and we can pivot the rib on the back joint, on the costovertebral joints. So what we do is we have our breastbone here and we lift it and we lower. Lift and lower. So rather than me pivoting this way, the rib is moving up and down. It's moving up and down a little bit like the handle of one of those old farmyard pumps that would pump up and down. And so that is known as pump handle movement. So expanding the rib cage forwards and up and taking the breath into the upper regions of the chest is called pump handle breathing. And expanding the rib cage sideways and taking the breath into the side of the lung here is called our bucket handle movement. So we've got movements of the rib cage because we have the rib cage joined at the front and the back.